Well, so again, we are starting from kinematics. Rather, we are continuing the portion of kinematics, and that too in the motion in plane. And our topic is circular motion. And in circular motion, we have to go through with centripetal force, centripetal acceleration. Then we have to go through that how the particle in circular motion behaves with respect to its uniform acceleration, uniform velocity, the variable velocity, the radius vector. So these facts are to be taken into consideration. So in circular motion, basically when the particle is moving in uniform circular motion, the very important fact is that at any instant of time, the radius vector is at right angles to the velocity vector. So whenever particle is moving in uniform circular motion, we find that the speed remains constant at the different instants of time, but velocity is represented by drawing a tangent at a point at that time. When the direction of particle will change, there is no change in the radius vector, but there is change in direction of the particle, so velocity will change. Therefore, speed will remain constant, but velocity at different instants of time will be different. Similarly, the acceleration is always directed towards the center. Centripetal force will be towards the center, and that will be given by function mv square over r. Now, most of the time we will use angular displacement. So, when we speak linear displacement, it means particle is in straight line. But when it is angular displacement, it means particle is moving in an arc or in a circle. Similarly, angular speed, that is given as omega is equal to v over r. These facts are to be used in the various parts of circular motion. Now, first of all, we will discuss about the fundamental parameters of the circular motion. What are the fundamental parameters of circular motion? First of all, we have to go through the radius vector. As you are seeing in the figure, that is O to P in the figure is radius vector directed towards P. OX and OY are the x-axis and y-axis, and the angles are given as theta 1 and theta 2. Delta theta is the change in angle. So the arc representing the arc which is meeting at P, that is representing the angular displacement. So what is radius vector? That is the line joining the center or the origin with a point on the circular path is called the radius vector. The vector joining the center of the circle and the particle performing circular motion is called radius vector. It has constant magnitude and variable direction. Now we come towards angular displacement, and again we consider the same figure. Angular displacement is indicated by arc which is meeting at P. Theta 1, theta 2 are the two angles, and change in angle is delta theta. R is the radius vector. The angle described by the radius vector is called angular displacement. When we use the term linear displacement, it is the distance between the 2 points in a plane in a particular direction. But now it is angular displacement, so obviously the particle is moving in circular motion. The angular displacement is a vector quantity. SI unit of radian, so SI unit is radian, and dimensions for the angular displacement m naught, L naught, T naught, that is dimensionless quantity. 1 radian according to trigonometrical calculations will be 360 over 2 pi, because 360 degrees is 2 pi radians, so it will cancel off and it will become 1 radian. Number of revolutions, that is taken as angular displacement divided by 2 pi. In 1 revolution, delta theta is equal to 360 degrees, and 360 degrees will be 2 pi radians. So for 1 revolution it is delta theta, so for n revolutions it will be 360 degrees multiplied by n. 360 degrees are replaced by 2 pi, and the net function will become 2 pi n radians. The clockwise rotation is taken as negative and the anti-clockwise rotation is taken as positive. Angular velocity, like one is linear velocity, that is the rate of change of displacement, that is called linear velocity. But now it is angular, so obviously the particle is moving in circle. So angular velocity is represented by omega. The rate of change of angular displacement with respect to time is called angular velocity. It is a vector quantity. The angle traced per unit time by radius vector is called angular speed. Instantaneous angular velocity, mathematically given by omega, equals to limit delta t approaching to 0, delta theta over delta t, or omega is equal to d theta over dt. Average angular velocity, we take the difference of two angles divided by difference of two times. So omega bar is equal to theta 2 minus theta 1 divided by t2 minus t1. Theta 2 minus theta 1 is replaced by delta theta and t2 minus t1 is replaced by delta t. The SI unit is taken as radian per second. As it is clear in the numerator, it is delta theta, so that will be in radians, and delta t will be in seconds, so the SI unit will become radian per second. Now in the adjoining figure, we are finding that the particle is moving in clockwise as well as anti-clockwise direction. If it is moving, if the axes are downward and it is moving in clockwise direction, then the angular velocity, that will be taken as negative. But if it is anti-clockwise, it should be taken as positive. So it is clear from the figure, the upper portion is indicating downward motion, that is clockwise, and upward motion, that is anti-clockwise. So omega is positive or negative depending upon whether it is clockwise motion or it is anti-clockwise motion. The dimensions will be m naught, L naught, t minus 1. That is inverse of time. The direction, angular displacement and angular velocity are vector quantities whose directions are given by that right-hand rule. We have earlier discussed about the right-hand rule. That is, imagine the axis of rotation to be held in the right hand with fingers curled round the axis and the thumb stretched along the axis. If the curved fingers denote the sense of rotation, then the thumb denoted the direction of angular velocity and the angular displacement. Now, what is angular acceleration? Represented by alpha. Like the linear acceleration is rate of change of velocity, the angular acceleration means rate of change of angular velocity. So, the rate of change of angular velocity with time is called angular acceleration. The average angular acceleration is given by function bar alpha equal to omega 2 minus omega 1 divided by t2 minus t1. The difference of angular velocities will be delta omega and difference of time will be delta t. Omega 1 and omega 2 are the angular velocities, the final and initial, and the difference is the change in angular velocity. T1 and T2 are the instants of time for omega 1 and omega 2, and their difference is delta t. Now, instantaneous angular acceleration is given by alpha, that is d omega over dt, where omega is the angular velocity. So, rate of change of angular velocity is called the instantaneous angular acceleration. In the form of calculus, it is written as d square theta over dt square. That is double derivative of theta with respect to time. It is a vector quantity whose direction is along the change in the direction of angular velocity. The SI unit of angular acceleration is radian per second square, and the dimensions will be m naught, l naught, t minus 2.